Good morning, students. In the last class, we discussed about the classification of elements. So mainly I already told you that there are mainly four types of elements like S block elements, P block, D block as well as F block elements. Right? Yesterday we discussed about the S block elements. Now in today's class, let us discuss about P block elements. Okay, somebody else. The second type of elements in the periodic table, that is P block elements. As we already discussed about S block elements, now it will be easy to understand what is meant by P block elements. Okay, so it is very clear P block elements. So from the definition of S block elements, we will come to know what is meant by P block elements. Okay, how we define S block elements? The elements in which the last electron entered into S orbital. Okay, so those are called as S block elements. Now coming to P block elements. This means what? The elements in which the last electron, what we call the last electron? Differentiating electron. Okay? In any element, the last electron enters into P orbital. Then such type of elements are known as P block elements. Okay? So first note down the definition. The elements in which the differentiating electron So what is meant by differentiating electron? Differentiating electron means the last electron which is entering into the element. Okay, that is known as a differentiating electron, or you can write it as simply the last electron enters into P orbital, are known as P block elements. Okay, so how can we define the P block elements? Means the elements in which the last electron enters into P orbital. So such type of elements are known as P block elements. Okay, if they give a particular element, how can we identify the given element is a P block element? Okay, generally in the definition it is given clearly that the last electron should be in the P orbital. Okay, so if you observe the P orbital, what is the capacity of P subshell? We know a P subshell means we will write it as 3 blocks Px, Py, Pz. So how much is the total capacity? We know each one can accommodate 2 electrons. So total P orbital P subshell capacity is 6 electrons, right? So if any element is having N means what? Any orbit number, 2p, 3p, any p orbital, if it has only one electron, okay? If it is having the electronic configuration as a np1, okay? When n means a principal quantum number, we know 2p, 3p, anything, has a p1, it will be a p block element, okay? If it has np2, it will also comes under P block. Like that up to how much? np6. Okay? The elements with the np1, p2, p3, p4, p5, p6. Right? So how many groups will be comes under P block elements? Right? capacity of p orbital is 6. Okay, so p1 to p6 we will find 6 groups. So that is why under p block we will find 6 groups. Right? What are the 6 groups? We already discussed about the general electronic configuration of each and every group. Once you cross check that one, if you open that one, if you cross check, you will come to know what groups will be comes under that. Otherwise, let us see the electronic configurations. For example, whether the electron is going to enter into p orbital means it's already the s orbital is completely filled, right? Understood the logical method? The electron is entering into p orbital means already it is entered into s orbital. So ns2, what can be here? np1, np2, 3, 4, 5. It can be up to 6. So all these 6 groups will become under p block elements. So if it is having ns2, np1 configuration, how many valence electrons are there? 2 plus 1, 3 valence electrons are there. So when 3 electrons are present means it belongs to which group? We already discussed. After 12 onwards, whatever the groups are there, from that if we subtract, we are getting the valence electrons. In the same way, to this number of valence electrons, it is a p block element. So if we add 10, so 3 valence electrons plus 10, so total it will become 13. So it means the element belongs to 13th group. Okay? There are 3 valence electrons, so we can see it is belongs to third A group. Okay? Let us look at another example. ns2np4. Right? How many valence electrons are there? There are 2 plus 4, 6 electrons are there. So 6 plus 10. So this is electronic configuration for 16th group. Okay? Or there are 6 valence electrons. Nothing but we can say simply as it is belongs to 6th A group. Okay? So in the case of p block elements, to find the group number, we have to add 10 to the valency electrons. Okay? Now, this is what ns2np126 is the general electronic configuration. General electronic configuration of p block elements. Okay? So for s block elements, the general electronic configuration is ns1 to 2. Okay? But coming to p block elements, the general electronic configuration is ns2, np1 to 6. Okay? So coming to the groups which will become under that one, it will be like from third A group to 0 group. Okay? Third A, fourth A, fifth A, sixth A, seventh A as well as 0. Or indirectly the other numbers, simple normal numbers wise if you go, p block elements means from 13th group to 18th group. Okay? So 13th group to 18th group. So total 6 groups will be comes under p block elements. Okay? So if you observe the periodic table also, the extreme left hand side there will be first 2 groups S block. And middle you will find D block. At last there will be last 6 groups are P block elements. Okay? So from 13th group to 18th group. These 6 groups will be considered the P block elements. Now, let us discuss about the general properties of P block elements. As we already discussed general properties of these S block elements, as well as regarding the P block also, individual group wise I already explained to you. Now, collectively, the common properties of all these P block elements, let us discuss. If you observe first, the general electron configuration, if you observe, it is NS2, NP, 1 to 6. Now, based on that, if you observe the oxidation state, in the case of first S block elements, we can say they will exhibit either +1 or +2. But because of these many electrons in the valency shell, these elements, P block elements, shows different oxidation states. Okay? But coming to the nature of these elements, P block elements includes metals, non-metals, as well as metalloids. Okay, so P block elements contains metals, non-metals, as well as metalloids are present in the P block. Because of the presence of different types of elements, these elements can form both covalent compounds as well as ionic compounds. Can form both covalent compounds and ionic compounds. Okay? They form both covalent compounds as well as ionic compounds. Generally, we know metal ions or metals will form ionic compounds. Non-metals generally they will form covalent compounds. In the previous case, we discussed those are highly electropositive elements. S block elements are highly electropositive elements. They act as good reducing agents. But coming to these non-metals in the P block act as good oxidizing agents. Okay? These non-metals in the P block will be act as good oxidizing agents. Means they oxidizes the other elements easily. Now, coming to the melting and boiling points. Generally, metals will have high melting and boiling points. Non-metals will have low melting and boiling points. So these elements have low melting points and boiling points. Okay? And even coming to the conductance. Normally, metals are good conductors of heat and electricity. But coming to the non-metals, these are bad conductors of heat and electricity. Okay? Due to presence of free electrons, these are bad conductors of heat and electricity. Right? So these are the common properties of P block elements. Note on this. Now coming to the next D block elements. I think now you are able to tell the definition of D block elements. Okay, based on S block elements and P block elements definition, we will come to know what is meant by a D block element. What is meant by that one? The elements in which, out of the definition, the elements in which the last electron means what? Differentiating electron enters into d orbital, are known as D block elements. Okay, the elements in which the differentiating electron enters into d orbital are known as D block elements. Okay, now my question is, how many groups will become under D block elements? Okay, means how many types of elements? Groups are equal to what? Here D orbital, if you observe, what is the capacity of D orbital? We know D orbital means there will be D subshell contains 5 D orbitals. So what are the D orbitals? Everything you know. So what is the capacity of D orbital? Its capacity is 10. So the elements with D1 configuration, D2, D3, D4, like that, up to how much? Up to 10, because its capacity is 10 electrons. So that is why the elements which are having the configuration, the last valence shell having the configuration from D1 or D2 or D3 or up to D10, all those elements will become under D block elements. Okay? So its capacity is 10. So 10 groups will be comes under D block. Okay? Understood the logic? It will be very easy thing to remember. S orbital capacity 2 electrons. So that is why S block elements are 2 groups. P orbital capacity 6. So that is why under P block you will get 6 groups. But coming to D orbital, its capacity is 10 electrons. So that is why 10 groups will become under D block. Okay? So if you observe the periodic table, the extreme left hand side, so these 2 groups will be comes under S block. Okay? And the same way if you observe there, here you will find 6 groups. So those 6 groups will be comes under P block. So this is S block. Now middle whatever is there, these 10 groups will be comes under D block elements. Okay? So remember that which groups will be comes under D block, we should have that. Okay? In the periodic table, in extreme left, the first 2 groups will be S block. From the last, these 6 groups will be comes under P block. Means from 13th group to 18th group will be belongs to P block. Okay? So this is first group, this is second group. Now D block means from third group to 12th group. Okay? Third to 12th. These 10 groups will become under D block elements. Okay? No. which groups will be comes under D block? From 13th, sorry, from third group to 12th group will become under D block elements. Instead of these normal numbers, in terms of other way, means in terms of Roman letters, we have idea about the numbering. So third group will be third B group. 12th group, if you observe, the 12th group is the second B group. So these 10 groups will become under D block elements. Okay? So somebody will get confusion. Sir, how it is a third B to second B, 10 groups. That's why given clearly the order of the groups. If you observe there, third B, fourth B, like that up to 8 groups. Then comes the first B and the second B. Okay? So the third group in the periodic table is a third B group. And the 12th group in the periodic table is a second B group. Okay? So remember this one clear. Now coming to a very important one regarding D block elements. It is the general electronic configuration. The general electronic configuration of D block elements was asked many times in the previous years. Okay? Whether it is JEE examination, NEET or AIMS or KSET examination, any type of competitive examinations, they asked the general electronic configuration of D block as well as F block. Okay? So most commonly they are asking about D block elements general electronic configuration. Okay? Because S block and P block is a very easy thing to remember. The students generally will do mistake regarding the configuration of D block and F block. So that is in competitive examinations they are asking general configuration of D block as well as F block. Okay? As we all know that based on the S block, D block, simply we can say the D orbital case. D block means we can simply say it is from 1 to 10. There is no doubt at all. It is 1 to 10 only. But if you observe the electronic configuration of D block, it is like NS 1 to 2, N minus 1, D 1 to 10. This is the general electronic configuration of D block elements. Okay? NS 1 to 2. N minus 1 D 1 to 10. Okay? In a very few cases, even we can say its electronic configuration is from even NS 0 to 2 also. Okay? Because in the case of palladium, we are observing NS 0 configuration. If they give NS 1 to 2, it is okay. Even exactly if you want to say NS 0 to 2 is better to follow. Okay? N minus 1, D 1 to 10. So immediately some of you may get doubt. First time while you are listening. Sir, why it is N minus 1? Previously we written NSC NP. But in this case, we are writing N minus 1. Okay? So why we are writing like that? To understand that, let us look at the electronic configuration of one of the D block elements. That is, let us write electronic configuration of scandium. We all know scandium atomic number 21. If you observe the electronic configuration of scandium, it is argon 4s2 3d1. Right? If you observe for iron, like 26th element, its configuration will be how much? 4s2 3d6. The next element we have 3d7, 3d8, like that 3d10. Okay? So if you observe the orbitals, According to off-bow principle, we know the electrons enter into the orbitals with the lower energy based on their n plus L values. We discussed already about electronic configuration. So if you observe this, the electron before entering into 3d orbital, the electron entered into 4s. Okay? So the last orbit is the nth orbit. Okay? For example, this is the center of the nucleus and we have 4 orbits are there. This last orbit is nth orbit. Okay? What will be the next orbit from the last? So this is n minus 1th orbit. Okay? So from the last, second orbit is known as n minus 1th orbit. Even if you go inside, n minus 2. Correct or not? This is 4th orbit, this is 3rd, this is 2nd, this is 1. Okay? So last orbit is known as nth orbit. Before that last is known as n minus 1. So that is why here the electronic configuration is given like this. Okay? This s orbital belongs to last orbit, but the d orbital belongs to the last second orbit. So that's why the general configuration is written as ns 0 to 2, n minus 1, d 1 to 10. Okay? Is your doubt is clear or not? So observe that one. I think you may get one more doubt. Sir, here we are writing 4s2 always. So why don't you write simply as ns2? Why we are writing as ns0? ns0 means it can be ns0, ns1 or it can be ns2. ns2, okay, it is quite regular. When it will be ns1? You already know about the electronic configuration of chromium. Chromium valence configuration what? 4s1, 3d 5. Okay? So in this case, s orbital is having only one electron. Now, in the same way, if you observe copper, in the case of copper also you will see ns 4s1, 3d 10. Right? So in this case also there is only one electron in the s orbital. So it will also be concerned with this. Okay? Is a d block element because the last electron is present in d orbital. So these are d block elements. So, but they are having only one electron in the s orbital. Then in which case we will find the ns is 0. It is a very rare case. Mainly in the case of palladium, sometimes in the platinum also. Actually, if you observe palladium, it will have 5s2, 4d8 it should have. But instead of this, palladium will have configuration as 5s0, 4d10. Okay? In the same way, platinum also some cases will have 6s0, 5d10. So because of this exception, the general configuration is given as 0 to 2. Okay? Except in this case, we can say simply as ns1 to 2. So that is in some of the textbooks. They are giving it as ns1 to 2. But including this exception also, the exact configuration is like a ns0 to 2. Okay? So note down this one clearly. Now, let us discuss about the general properties of d block elements. Now, Coming to the general properties of D block elements. First of all, one common point between all these D block elements is all are metals. Okay? All the D block elements are metals. There is no doubt at all. Because in the case of P block, it includes metals, non-metals as well as metalloids. But coming to S block and D block, all these contains only metals. If all are metals, what about their physical state? Generally metals means solids. But coming to this D block, all these are solids. Even these are hard when compared to S block. Because in the case of S block, you written it as they are soft solids. But coming to these P block, D block elements, these are hard solids. Okay? But there is an exception. Except only one metal, that is mercury. Except mercury, all the remaining are hard solids. You know already about mercury. What is the physical state of mercury? We all know mercury is a liquid. In the thermometers, we have seen that mercury will be filled. That is present at the room temperature in the liquid state. Okay? So in the case of D block elements, all are metals as well as solids. But except one metal, that is mercury. Okay? Coming to P block elements, if you observe, P block elements are metals and non-metals as well as metalloids. So it contains mainly metals means solids, non-metals generally gases are there. But there is a one non-metal, bromine, which is in the liquid state. Okay? So out of the periodic table, if you observe, generally most of the metals are solids except mercury, which is a liquid. Okay? In the same way, most of the non-metals are generally, if you observe, mainly these last noble gases, halogens, these are purely gases. But except one, that is bromine, which is the non-metal present in liquid state. Okay? Now, coming to the other properties of these D block elements, here they have high melting points and the boiling points. Okay? Because these are hot in nature, so due to that they will have high melting points and the boiling points. Coming to the other important property of these D block elements is they exhibit variable oxidation states. D block elements exhibits variable oxidation states. This is one of the important property of D block elements. So variable oxidation states means S block elements case we have seen. Individual group wise we discussed. Generally the element exhibit only one oxidation state. First group elements exhibits only +1. They don't exhibit different oxidation states. Right? Second group also exhibit +2 oxidation state only. Like for example, magnesium or calcium, if you see, they exhibit only +2. They never exhibit other oxidation states. But coming to D block elements, most of these elements exhibits variable oxidation state. Okay? Means one element can exhibit different oxidation states. For example, a well-known example for you, that is iron. Right? Iron exhibits 2 oxidation states, +2 as well as it exhibits +3 also. Okay? Iron case plus 2 means ferrous, plus 3 ferric. In the same way, if you observe the different elements like manganese, if you observe, manganese can exhibit oxidation states from plus 2, plus 3, plus 4, plus 5, even plus 6. Also it can show plus 7. Okay? So that is why we say that most of the transitions or D block elements exhibits variable oxidation states. Okay? But all these elements, all these D block elements commonly exhibits one oxidation state. Okay? All the D block elements exhibits one common oxidation state. So this was also many times they asked in competitive exam. The common oxidation state of D block elements is, remember, it is plus 2. Okay? So most of the D block elements exhibits plus 2 oxidation state. There is only one exception. Except scandium, which shows plus 3 oxidation state. Okay? Except scandium, most of these D block elements exhibits a common oxidation state as plus 2. They exhibit other than plus 2, like plus 3, plus 4, they exhibit. But commonly most of them exhibits a plus 2 oxidation state. Okay? Note down. Now coming to the other properties of these D block elements, if you observe. One of the important properties, they are good conductors of heat and electricity. Okay? All these are metals, so due to presence of free electrons, they act as good conductors of heat and electricity, as well as they act as good catalysts also. We all know about this word, catalyst. Catalyst means which alters the rate of reaction. Okay? So generally positive catalyst means it increases, it speeds up the reaction. So all these D block elements, generally most of them will be act as good catalysts. Okay? Generally in the lower classes we learned the hydrogenation of oils will be done in the presence of nickel as a catalyst. Okay? So in many cases these metals will be act as good catalysts. Okay? Even they form complex compounds. Okay? Maybe you know about this one, complex compounds, or even further we will discuss separately about this complex compounds. Even as a summary lesson in second PU, we will discuss about this complex compounds. Next. Even they act as good reducing agents. Generally we know that metals act as good reducing agent. When compared to P block elements, these are strong reducing agents. Okay? But when compared to S block, these are weak reducing agents. Okay? Some other properties like we know that they will have high melting and boiling points as well as they are hard in nature. So those properties we already discussed. So furtherly note down these properties also. Okay. Now coming to the last category, that is F block elements. So as we all know, we discussed S block, B block, D block. Now coming to F block, you are able to write the definition by your own. What is that? The elements in which the last electron means the differentiating electron enters into F orbital are known as F block element. Okay? Definition wise we already discussed. Right? F block elements means the last electron enters into F orbital. So these are known as F block elements. Right? Now, coming to the F block, we know the position of F block is different from S block, P block and D block. Okay? So first note down the definition, we will discuss clearly about the location of F block elements in the periodic table. Generally, if you observe the periodic table, this F block as a separate block, they will be placed at the bottom of the periodic table. But that is not the correct location of F block elements. Where are F block elements means generally F block element contains two series of elements. Okay? F block elements mainly contains two series of elements. They are known as lanthanides as well as coming to the other one. These are known as actinides. And then you know this information. A block element includes two type of elements. One is the lanthanides and the other one is actinides. Lanthanides means they will be concentrated from 57 to 71. Okay? Actinides are from 89 to 103. So these elements generally comes under F block elements. Okay? So if you observe the exact location of periodic table, we don't say that they will be present at the bottom of the table. Okay? Actually, these lanthanides and actinides are present in third B group. Must observe the table clearly. The F block elements belongs to, they will be present in third B group. Third B group means what? Third group in the periodic table. Okay? So first, second, third. So that left side, third group is the location of both lanthanides as well as actinides. They will be, if you observe the lanthanides, lanthanides are present in third G group and sixth period. Okay, lanthanides are present in third B group, sixth period. If you observe the table, you will find a block La. Okay, that is the elemental lanthanum. that is a D block element, but the elements followed by lanthanum, okay, means mainly the elements, generally we say from lanthanum to lutetium. Lanthanum is 57, lutetium 71, okay. The elements after lanthanum means 58 onwards, 14 elements will become under lanthanide series, which are known as F block elements. In the same way, actinides, these will be belongs to third B group and seventh period. Okay. This is the location. If you observe the elements in the third B group, seventh period, if you observe, you will find the element AC. You will find a block. So all these elements, actinides, will be belongs to that block only. Means the elements followed by actinium are known as actinides. If you observe actinium, its atomic number is 89, and next thorium will be there. So means from this 90 to 103, that is LR, known as Lawrencium. Okay, so actinium to Lawrencium means the elements, 14 elements from thorium to Lawrencium. These 14 elements will be belongs to actinides. Okay. What is the location of F block elements? F block elements, generally we say it is at the bottom of the table, but the location in the periodic table is they belongs to third B group, both sixth period as well as seventh period. Okay, lanthanide belongs to third B group, sixth period. Actinides belongs to third B group, seventh period. Okay. Note. Now, coming to the general electronic configuration. I already told you the general electronic configuration of both D block elements and F block elements is very important. Their general electronic configuration is NS2 N minus 1 D 0 comma 1 N minus 2 F orbital capacity is 14. So that is why the elements with F1, F2, F3 up to F14 will become under F block. That is where lanthanides, how many we are getting? 58 to 71. So 14 elements we will get. In the same way, actinoids also 90 to 103. So those 14 elements, why we are getting particularly 14 means because the F orbital capacity is 14. Okay. So if you observe thorium, it will have F1. The next element F2. Like that, the 14th element will have F14. Okay. In detail about lanthanides and actinoids, we will discuss in F block elements, right? The minimum basic information only let us discuss in this. So remember this general electronic configuration. For F block, NS2 N minus 1 D 0 comma 1 N minus 2 F 1 to 14 means what? The S orbital belongs to last orbit, nth orbit. This D orbital belongs to N minus 1. Most of the cases the D will have 0 electrons only, but in very rare cases to get half filled or completely filled configuration in F block, F orbital, 1 electron will be jumps into D block. Okay? So that is why most of the cases D is 0, but rarely it will have 1 electron. That is why n minus 1 D 0 or 1. N minus 2 F 1 to 14. Okay. So this is general electronic configuration of F block elements. Now let us discuss about the general properties. Now one of the common properties, all are metals, as well as these are generally called as heavy metals. Okay. Why we use the word heavy? Because they will have very high atomic mass. That's why these are called as heavy metals. Okay. But the common point is all the F block elements are also metals only. Okay. S block, D block, F block. All these three block elements are purely metals. Okay. So in the periodic table, whatever the non-metals, whatever the metalloids are present, all are present in the P block. Okay. Now one more important note regarding this is, these are also electropositive elements, they are also reactive metals. But if you observe the reactivity, compared to S block and D block, these are somewhat less reactive. Okay. Even the common properties are same. These will have metals, means they are malleable, they are ductile, as well as they act as good reducing agents. So again, those properties I am not writing here. Okay? Because about metals means we all know about this. I'll write few points like they will have high melting points and boiling points. Even these can also form complexes. Okay, means they can form complex compounds. Okay, but the important point we need to remember about these F block elements is when compared to D block, they don't show variable oxidation states. Okay, when compared to F block, D block they will show less tendency, but the common oxidation state is common oxidation state of these elements is plus 3. Okay. So remember this point that for the D block elements the common oxidation state is plus 2. But coming to these F block elements the common oxidation state is plus 3. Okay. In detail about the remaining properties, anyway in the F block elements lesson we will discuss. Okay. So how they will be, we should have clarity here. Now one more important note is, if you observe actinoids, all the actinoids are radioactive elements. Okay? Most of these actinoids are radioactive elements. You know about radioactivity. In the atomic structure lesson we discussed it. Radioactive element is what generally they will emit radiation. You know about the radium, because we use it to play with these radium balls. Okay, they disintegrate the particles like alpha particles and the beta, gamma rays. Right. So most of these actinoids are radioactive. Generally coming to lanthanoids, there is only one element, promodium. Promodium is the lanthanoid which is radioactive. Okay, everything in the F block elements we will discuss. Right. So this is about the classification of elements into SPDF blocks. Okay. Note down all these. About the next classification we will discuss in the next class. Thank you.